In this video, we are going to explain the chapter Haloalkanes and Haloarenes, class 12. In the last video, we have seen the chemical reaction, that is the nucleophilic substitution reaction of haloalkanes. Now in this video, we are going to explain the another chemical properties, which is elimination reaction for haloalkanes. What happened in an elimination reaction? From the name we can see that there will be elimination of any compound or any group after this reaction from the alkyl halides. So in this reaction, when an haloalkane is heated with a concentrated alcoholic solution of potassium hydroxide, then a molecule of halogen and the hydrogen, they form together hydrogen halide and is eliminated, and after that one alkene is formed. So if this is the potassium hydroxide in alcoholic medium, this is our alkyl halide, where this is the halogen bromine, then the hydrogen and the bromine are eliminated in the form of KBr and H2O, and we get one alkene or a double bonded compound. So this is the elimination reaction. So what happened in this reaction? If I see in the mechanism, we can see that the OH group of the potassium hydroxide is taking the hydrogen from the beta position. That means the halogen is attached with the carbon, which is known as the alpha carbon, because we know that functional group is attached with the next carbon, that is the alpha carbon, and after alpha there is the beta carbon. So the hydrogen is taken up from the beta hydrogen and the halogen is coming from the alpha hydrogen. So the HBr is eliminated by this way. The OH minus is taking hydrogen, the CH bond is breaking and it is making the CC double bond, and the bromine will be eliminated, and that is how we are getting a double bond or one alkene. So this is the mechanism of elimination reaction. Basically this type of elimination reaction is known as E2 elimination reaction, where both the base and the alkyl halide are involved in the single step reaction, and just like the SN2 reaction, both the reactant and the reagent are involved in the step of the reaction. So it is E2, that is bimolecular. There are two different types of elimination also, that is E1 and E1CB, but that is not involved in the CBSE syllabus. So this elimination is occurring by the elimination of the halogen from alpha carbon and the elimination of hydrogen from the beta carbon. Since the hydrogen is eliminated from the beta carbon, that is why this elimination reaction is known as beta elimination reaction. Now how we have to write down the product of this reaction? If we see that this is our substrate or reactant, that is 1-chlorobutane, then we can see the halogen is attached in the corner carbon, and that is why there is possibility of formation of only one product. So the halogen from the alpha carbon, the corner carbon, is taken up, and the hydrogen from the next carbon, that is beta carbon, is eliminated. So there will be formation of double bond in between the alpha and beta carbon, and we will get one butene. But if there is the halogen in the second carbon, that is the reagent is here, which is the 2-bromobutane, then we can see regarding this alpha hydrogen or alpha carbon, there is beta position, 2 beta position. That means one carbon will be this one, which is beta, and again this carbon is also beta. So there will be probability of formation of two products. One will be from this side where the hydrogen is taken up from this carbon and bromine will be eliminated. In that case we will get this product which is but1-ene. But in case of the elimination of hydrogen from this beta carbon will give us the product but2-ene. So how to determine which one will be the measure product? The measure product is determined by the rule that is called Sitjeff rule. According to this rule, the more highly substituted alkene, that means if this is the carbon-carbon double bond, then there will be 4 hydrogen maximum. But if in any substituent or any product there are less hydrogen and more functional groups like methyl, ethyl, like this group, alkyl group, then that is called the double bond with more substituent. So according to Sitjeff rule, the more substituted double bond or more substituted alkene will be the measure product. So between these two, but1-ene and but2-ene, we can see that in this case the carbon-carbon double bond is having 3 hydrogen and 1 ethyl group. But in case of this one, but2-ene is having 2 hydrogen and 2 methyl group. So more substitution is in this case, means but2-ene. So the but2-ene is more substituted double bond, and regarding the Sitjeff rule, this one will be the measured product. So when there is chance of formation of two product, we have to look after about the more substituted double bond, and that will be the measured product in case of elimination, beta elimination reaction. Now we have seen that in case of substitution reaction we can use OH minus as nucleophile, but in case of elimination reaction the same OH minus is acting as the base. So we can easily understand there will be a competition between the elimination and substitution reaction. So when an alkyl halide is having beta hydrogen, then either it will be treated as base or nucleophile. Then we can have two competing reaction, that means substitution and elimination. Which one will occur when? That will depend on the some factors. They are nature of alkyl halide, strength and size of the base or nucleophile, and the reaction condition. We can observe one factor here, that is we have taken the same substrate, that is the carbon with 2 methyl group, 1 hydrogen and 1 bromine. So if the same substrate is treated with tertiary butoxide ion one time, then because of the size of this ion it will act as base rather than acting as nucleophile. So this base will take up the beta hydrogen and we can have the elimination product, that means the formation of a double bond, that means alkene. But if we are taking the OH minus, then it can easily attack the carbon from the back side and there will be substitution reaction and we can have our product, that is the substituted product, that will be alcohol. So depending on the steric factor, means depending on the size of the nucleophile or base, a substrate will act as either base or nucleophile. So by this way elimination and substitution reaction are two competing reaction and they will be decided on the factors which we have already told. The next chemical property of haloalkane is the reaction with metal. For the first reaction on this category is the formation of Grignard reagent. Grignard reagent is basically the alkyl magnesium halide. How this is formed? This is formed by the reaction of alkyl halide with magnesium in presence of the solvent dry ether. So the alkyl halide is converted into RMgX. This RMgX is the Grignard reagent. So here we can see the R group in alkyl halide was delta positive because of the electronegativity of carbon is always less than the halogen. And here we can see the R group is delta minus, that means the carbon is less electropositive than magnesium, so it will be carbon will be delta minus and magnesium will be delta plus. So here we can see that there is change in polarity of the alkyl group. This is known as Ompolang, and the carbon has been converted into nucleophilic center from an electrophilic center. This polarity change makes the Grignard reagent very useful reagent for any organic synthesis reaction. Here also we can notice that I have used dry ether in case of the solvent. Why dry ether only? Because the Grignard reagents are very reactive towards moisture. So if there will be presence of moisture, then it will react with the moisture and it will give hydrocarbon. So our desired product, which is Grignard reagent, that will be destroyed. So we use dry ether as a solvent. Here we can also see that the R, that means the carbon part, and the magnesium, that means a metal, has formed a bond. This type of compound where the carbon is forming bond with a metal is known as organometallic compounds. So Grignard reagent is a very important organometallic reagent also, which is very useful for the synthesis of different functional groups in organic reaction. After that we can see another reaction of haloalkanes, that is Wurtz reaction. Wurtz reaction we have already learnt in class 11th also, that is when an alkyl halide is reacting with sodium in presence of dry ether, it will give a symmetrical alkane. That means there will be both R group, and both R group will coming from the haloalkane or the alkyl halide. So here if we use methyl bromide, then we can have ethane as our product. So we can easily observe that the number of carbon is becoming double than the alkyl bromide. Alkyl bromide is containing one carbon, but here the product is having 2 carbon. So Wurtz reaction is very useful for synthesis of symmetrical hydrocarbon and with the number of carbon double than the alkyl halide. So we can see methane cannot be prepared by Wurtz reaction, and Wurtz reaction also fails for tertiary alkyl halide. Why? Because tertiary alkyl halides prefer to undergo dehydrohalogenation, that means the elimination of HBr, and to form the alkene in this reaction condition. So our desired product, this one is not formed from tertiary butyl bromide, but we have the product, this one, in place of the targeted hydrocarbon. Also this Wurtz reaction is not a very good process for the preparation of unsymmetrical alkane. Why? Because if we are trying to preparing some alkane with 3 carbon, then we have to take 2 alkyl halide, one with 1 carbon and the other one with 2 carbon. So what will happen then? Then we can have mixture of products. That means the methyl bromide will undergo self condensation or self reaction, and it will have the product ethane. Ethyl bromide will also undergo the reaction with another molecule of ethyl bromide, and this one will give butane, and also they both will react with each other and they will give the reactant product, our targeted product propane. So there will be mixture of product and the haloalkanes are reacting and giving the mixture, and the mixture of alkyl hydrocarbons are not easier to separate. So this reaction is not a very good reaction for the preparation of unsymmetrical alkanes. So these are the chemical properties of haloalkanes which are very important for the preparation and the synthesis, which are also asked in the questions also, like Wurtz reaction, Grignard reagent. All this we have to use in case of preparation of one compound from the another compound.